Hey everyone, today we're going to start learning about precipitation reactions. And this section can be quite long, so I've split it into two parts to make these parts a little bit more manageable. So let's go ahead and start with part one. First, in order to understand precipitation reactions, we need to identify and define them. Precipitation reactions is defined by your textbook as a reaction between two solutes in a solution and it forms a precipitate, hence the name while it's called a precipitation reaction. And that's fine if you understand what a precipitate is. If you don't, that's why we've defined it down below. A precipitate is an insoluble solid, so generally these do not dissolve all the way. And these are going to form when two solutions are mixed. A precipitation reaction is generally going to be a double replacement reaction, and we talked about those when we went over types of chemical reactions. Sometimes they also might be known as exchange reactions or metathesis reactions. A common precipitation reaction that I have done in class is mixing lead to nitrate and potassium iodide. Both of these are soluble in water, hence the AQ after it, so they're going to be solutions as you see up above. However, when you mix them, you see a chemical change happen because of my change in color, and my products are lead to iodide and potassium nitrate. When you check these, you'll see that lead to iodide is actually a solid, and this tells me that this is my precipitate in my precipitation reaction, whereas my other one is going to be still in a solution. When you look at my final product, this yellow down here is a solid that is formed. Again, my lead to iodide, and the rest is my potassium nitrate in solution. Then I want to also point out on this slide is we said that these were double replacement. Notice the lead is with nitrate, but if you look in the product, lead is now with iodine instead. And potassium that was with iodine is now going to be with the nitrate. So they basically just switched partners. A precipitation reaction occurs because when these pairs of oppositely charged ions switch, the attraction is so strong that it forms that solid. We can't split them apart into their ions. So, to predict whether or not something is going to be insoluble, we have to consider guidelines for solubility. And this is why we had a whole lesson dedicated to determining if something is soluble or insoluble. You should have this table from that lesson, and you're going to be using it today. One thing to note is that these are called precipitation reactions. So if there is no insoluble compound, the reaction cannot and does not occur because there is not a precipitate. Today we're going to focus on how to finish the products for precipitation reaction and then determining if a precipitate actually forms. In order to do that, we have to follow 3 steps. First, we have to take note of the ions that are present in our reactants because our reactants are going to split into their ions when they're dissolved. Then what we need to do is we need to figure out our cation anion combinations. In other words, they have to switch partners. Lastly, we're going to use our solubility table to tell us whether or not what our products are, if they're soluble or insoluble. Here's an example we're going to walk through. The question we're going to try to answer is, will a precipitate form when solutions of magnesium nitrate and sodium hydroxide are mixed? Now, both of these are soluble compounds, so they're going to split into ions, and they're strong electrolytes because there's a metal in them. So what we need to do is first determine the ions that are present, and the way you do that is just like we've been doing on past worksheets, is uncross your charges. So when we uncross our charges, magnesium, you're going to know, has a 2 plus charge. When you uncross this one, nitrate, NO3, has a -1 charge. When you uncross sodium hydroxide, sodium has a +1, so +1, and hydroxide, if you uncross it, has a -1. So these are all my ions that are present. The next step is we have to figure out our possible combinations, which means a positive should pair with a negative. Opposites have to go together. Well, here I have a positive and a negative, and I don't want to recombine those because I'll get the same product. So I need to switch it. My magnesium needs to go with my other negative, which is hydroxide. So we have to cross my new pairs. So here, magnesium and hydroxide. So magnesium, and then if I drop this 2 on hydroxide, since that's a polyatomic, that gets a 2 on the outside. This is important to understand. We actually went over this at the very beginning of the school year, but if you're having trouble, I highly suggest you come in for more help. So that's why one of our products is magnesium hydroxide. The second pair is sodium was originally with my OH, so now my sodium needs to go with my other negative. So positive is always written first, and then here's my NO3, and I need to cross my charges, my 1, and then 1 crosses. So Na1 and then NO3, and you don't have to write the 1, which is why you get NaNO3. If you look at your solubility table, you're going to have to figure out if any of these two are soluble or insoluble. So first you would find OH on the table. So if I look at my solubility table, here's my OH. It says that it's insoluble, and I have to look at my exceptions. And you're going to notice that it does not fall into any of those exceptions. Magnesium doesn't. So it's considered insoluble, and this is my precipitate. NO3, if you look at the solubility table, NO3 is soluble, so that doesn't form a solid at all. So this is my precipitate. Now we can go through these other examples as well. First, the number one thing you need to remember to do is uncross your charges. So here, barium is a 2 plus, chlorine is a -1. If I uncross over here, sulfate is an SO4 2 negative. Now that 4 belongs to sulfate, so there was a 1 on the outside that uncrossed to give potassium a +1. Then you need to recombine to get your products over here. So when you recombine, my positive needs to pair with the negative. And so I'm going to recross those. Barium and sulfate. If I cross them down, 2 and 2, you originally get Ba2SO4 with a 2 on the outside. But remember, ionic compounds reduce, so my 2 charges reduce, and one of my products is barium sulfate. The other product has to be the positive with my negative. So my positive is always first, negative second, and I can cross my charges. So my next one is going to be KCl. Now you're going to see these blanks in the beginning, and that's just for balancing reactions. We'll worry about that on tomorrow's lesson. So when we have this, we then need to look at our chart. Well, is barium sulfate soluble or insoluble? So I'm going to look for sulfate and see that barium is one of my exceptions, so this switches down to be insoluble. So this one forms a solid. And then if I look for KCl, I find my Cl is soluble. There is no potassium as an exception, so this one stays soluble, so it's going to be AQ, soluble. That means barium sulfate, this is my precipitate. Let's do another example. Here, first thing you should automatically do is uncross your ions. So my 3's on the outside, so I can uncross it. Fe3 plus. Here, my 2 is going to uncross, so SO4, 2 negative. When I uncross over here, you get lithium has a +1, and then OH has a -1. And then you need to recross your new combinations to get your products. So remember, positive is going to go with my negative. So if I have Li +1 and SO4 2 negative, I need to cross this down. I get Li2, and then my 1 can cross down, but you don't have to write your 1, SO4. Next, my next possible combination is my positive iron and my OH. So Fe3 plus and then OH minus 1, if I cross them, you get Fe has 1 and then my OH. But since this is a polyatomic, I'm crossing down a 3, I got to put parentheses around it. Next, we need to determine solubility. So I need to find SO4 and see if lithium is an exception. So here's my SO4. Lithium is not an exception, so that means it stays soluble, or AQ. So this one stays aqueous. Here I have iron and hydroxide. Let's find hydroxide and see if iron is an exception. So here's my hydroxide. Iron is not an exception, so this stays insoluble, which is my solid. So my precipitate is my iron hydroxide. I want you to try these 2 examples on your own and then see if you get the right answer. So I want you to go ahead and pause the video and then we'll walk through them. Okay, let's go ahead and try to do these. Again, first we need to uncross our charges. So barium has a 2 plus, nitrate has a -1. If you uncross this one, potassium has a +1, hydroxide has a -1. Remember, my positive needs to pair with my other negative. So if I cross them, you get KNO3. And then here, my positive needs to go with this negative. So let's cross our new pair. And then OH -1. When I cross them, I get BA has a 1. OH, I'm crossing down a 2, but this is a polyatomic. So don't forget to put that in parentheses. Then we need to check our chart. Here's NO3. NO3 is soluble. There are no exceptions here. So it's automatically going to be AQ. And then hydroxide with barium. Here is hydroxide. Barium is actually an exception, so that makes this AQ as well. This tells me since everything is AQ, this is not a precipitation reaction. And then for our last one, let's do sodium and bromine. When we split them, we get a +1. Bromine gets a -1. When we split these, potassium gets a +1 and iodine gets a -1. So let's recross them. Potassium goes with bromine, so K, Br, let's cross them. And then here, sodium with iodine. So sodium and then iodine, when we cross those, we get NaI. Then we need to check our charts. Bromine with potassium. So if we look, bromine, potassium is not one of my exceptions, so it stays AQ. Here, iodine, I need to find iodine and see if sodium is an exception. So here's iodine. Sodium is not an exception, so it stays AQ. Note that I have AQ, 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 AQ. There's not a solid. So this also is not a precipitation reaction either. So what we're going to do on our homework is basically make our products and say if it is a soluble or insoluble. And then we're going to learn the second part tomorrow. So in the worksheet, I have instructions for part 1 and part 2. Make sure that you're only going to do part 1 instructions. And if you have questions, again, please make sure you guys come up and ask. And if you need additional help, I am always here before or after school. Remember, this is a weighted class, so it is a little bit harder and a little bit more work. So make sure that you guys are staying on top of it and keeping up with the material. Again, I hope you guys have a great day.